Hey guys, thought I'd go video today. I looked over your test results and I saw that some of the cost curves might be a little foggy for some of you. You guys haven't reached out to me, but I'm here for you if you want me to give you some additional explanation. So I'm going to give you a little bit of a rundown on some of the things that I think are important moving on through the rest of the course, especially in regard to some cost curves and how firms maximize profits, because this is critical whether we are into monopoly or any other sort of market structure. It's critical that you've got this down. So I got the whiteboard behind me. I want to go over perfect competition, and maybe I'll tie back in with monopoly as well. So the competitive market, if you checked out the graph that I drew in one of those video lectures, looks something like this, where you've got the general market here. Maybe this is the market for corn, big Q, and supply and demand intersect here, giving you a market price. Maybe it's $3 a bushel. And over to the right is the representative firm. Farmer Tom, Farmer Dick, Farmer Ted, whoever it is, one of the many firms that are operating in this perfectly competitive environment. And so that firm is a price taker. And again, if you want to review this without me going so quickly over it, it's on one of those videos at the start. We'll come to a graph that looks like this. And the demand curve and the marginal revenue curve lie on top of each other for this industry, because the revenue generated by an additional bushel of corn is the price that you can sell it for. In other words, that farmer will see an increase of total revenue by $3 in this example if it sells an additional unit of corn. So marginal, always be thinking additional, and that's our setup for perfect competition on the revenue side. Now, on the cost side, we need more information. And so the farmer cannot get away from the law of diminishing returns, and so therefore faces an upward sloping cost curve. And that's where we find out how this company can maximize profits. It's awfully tempting to think about this quantity here, and you saw this in some of your homework exercises. If the firm produces 100 units here, it seems like it's at the lowest cost possible and the revenue's up here, and so that would maximize profits, but that's wrong. That's where the marginal profit would be the highest, but we want the profit of the last unit to actually be 0, and here's why. If we are producing 100 units, you just need to ask yourself the question, what if I produced one more, the 101st unit? I'm going to sell it for $3, and it only costs me, I go up to the cost curve, marginal cost curve in this case, hang a left, read off that number. I'm going to make one up here, but let's just say it's $1. And so the farmer can make $2 worth of profit on the 101st bushel of corn. So he should do it. What about the next one, the 102nd unit? The revenue generated by the 102nd unit is $3. The cost went up, but it didn't go all the way up to 3. So the cost maybe went up to, again, just making up the numbers here, $1.30. So on that particular bushel of corn, the 102nd bushel, the profit would still be $1.70, $3 minus the $1.30 worth of additional cost from that unit. And so if you keep going through that, then logically you're going to want to go to the last unit where there's no profit, where the revenue generated by the last unit is equal to the cost of the last unit. That is the profit maximizing quantity. The same is true for any company in any type of environment. That's what marginal analysis is all about. That's what Chapter 3 was all about when we start, and Chapter 2 start looking at marginal benefits and marginal costs and making efficient decisions. Okay, so here the benefits are in the form of revenues for the company and the cost of the cost. All right, so how much money are they making depends on where their average total costs are. And quite frankly, it's possible that they're losing money, but they're losing the least amount of money possible as long as they are producing that quantity. And so if there's, let me give you the long run picture. In the long run, profits are zero due to entry and exit of firms. So the average total cost curve comes in here and just kisses that one as what the long run picture looks like. Why? Because by producing the profit maximizing quantity, the average cost per unit is $3. The average cost per unit is $3. Therefore, and with the price being $3, that means there's no profit in the long run. So that brings us back to our basic profit equation of total revenue minus total cost is the bottom line for any business. How much money came in, how much money went out, the difference is profit. Well, we can use these numbers here with the profit maximizing quantity. What's total revenue? It's the amount of money in the cash register. The price that we sold it at, which is the market price, times the quantity that we produced, which is this quantity, Q star, minus the total cost, where we can do a manipulation of total cost and think about the average total cost per unit times the number of units that I had. That gives us kind of a different way of thinking about the profit equation as the difference between price and average total cost times the quantity that we made. So that's kind of a helpful way to think about the profit equation as well. If we're in a monopoly, we learned that in monopoly and monopolistic competition that the demand curve is downward sloping. We don't have the perfectly competitive environment where it's perfectly elastic, but rather downward sloping. And that comes due to barriers to entry in the case of monopoly. In the case of monopolistic competition, it's due to differentiated product. That each hamburger, if we're looking at McDonald's hamburger versus Burger King's hamburger, they're differentiated. They're not different, but they're differentiated. All right, so with a downward sloping demand curve, a single price monopoly, if you're only allowed to do a single price, in other words, no price discrimination, gives you a marginal revenue curve that is twice as steep and lying below the demand curve. That's just the way the math works out when you've got a linear demand curve, which is what we deal with usually on the diagrams. And that being the case, our profit maximization problem looks a little different. We still have the upward sloping J-shaped marginal cost curve that looks like that. The firm maximizes profits by producing the quantity where the revenue generated by the last unit is equal to the cost of the last unit. But we're going to charge the highest price people are willing and able to pay. So we come up to the demand curve for that information. We hang a left, and we read off that price. That's the price that the monopoly is going to charge. This is the quantity that they're going to make. So I know I hit you with a lot of stuff. Hopefully you've gone back and reviewed since those last tests. If you're still having problems, contact me. I want to help you. Good luck this week on game theory, which is a little different than what we've looked at so far. And I think you'll find it fun. Most people do. Because with the strategic behavior is captured in that payoff matrix, and you kind of look at moves and counter moves, and your outcome is dependent on what your opponent does. And that's what's different compared here to perfect competition, is that each particular firm is just a drop of water in the bucket. They really don't have any impact on the market. Think about a farmer's corn. They're not worried about how much Farmer Harry's making, right? But in an oligopolistic market structure, then the firms are very interdependent. One firm's actions has consequences on the other. So again, there's some videos there that are embedded in the Blackboard that can help you work through some of those. I encourage you to look at those and reach out to me if you have any other questions. Have a good rest of the week. Look forward to your discussion board. Bye.